Hello, I'm Ms. Childers, and today we're going to be talking about changes in matter. Let's see. But before we talk about the changes in matter, we're going to talk about the law of conservation of matter and energy. The law of conservation of matter and energy tells us two major things about matter and energy. The first thing is that regardless of how substances are changed, the total mass remains the same. So regardless of what we do to a substance, the total mass, it's not going to make any difference. It's not going to change at all. The second thing the law of conservation of matter and energy tells us is that energy cannot be created or destroyed, but only change from one form to another. So when we have that energy, we're not creating new energy. We're not taking any energy away. What we end up doing is just taking energy in one form and moving it to another form. So the first change we're going to look at is physical change. A physical change is a change where the chemical composition of a substance does not change. So what the actual substance is made up of, what it is, that's not going to change. But how we know it's a physical change is if it changes shape, changes size, or if it changes phase, like it freezes, boils, evaporates, or condenses. Some examples of this would be ripping paper, melting ice, or boiling water. Now we're going to look a little bit more closely at physical changes. So it's a physical change if it changes shape. An example of this would be if you have a piece of bread. So you take your piece of bread and you put it in your hand and you smush it up. What you've got there is a smushed bread ball. So you've got that smushed bread. You haven't changed it from bread to anything else. It's still bread, but you've changed the shape of it. So that's a physical change. The next part we're going to look at is if it changes size. So say you've got a piece of paper. You take that paper and you give it a rip. You tear it down the middle and you throw a piece away. You've got that half a piece of paper. That half a piece of paper, it's still paper. So you've only done a physical change to it because it's just smaller. It's changed size, but it's still paper. The next part we're going to look at for physical changes is if it changes phase. So say you've got a glass of water and you take that water and you pour it into a pot, put the pot on the stove, turn the heat on, and it starts to boil and you get your evaporated water. Well, that evaporated water, that steam, what you're doing with that is you've still got water. You've changed its phase. You've changed it to a gas. But that water, still water, hasn't changed into any other new substance. So that is a physical change. And now we're going to be looking at chemical changes, and Ms. DiBartolo is going to tell you all about those.
Hello, class. So the next change in matter is a chemical change. And a chemical change is when a different or new substance is formed. And it is a chemical change. You can tell if it burns, if it bubbles, if it changes color, or if it forms a precipitate. And just to refresh, or precipitate is a solid that is separated from a liquid. And an example of this, a couple of examples, is burning paper, mixing baking soda and vinegar together, and rusting. And the difference here is that not is it just a physical change where you still have a bread from a bread ball, but you're actually changing the composition of the substance. So the compounds, the way that they react with each other are different. An example of a chemical change is something we are very familiar with, baking soda and vinegar. So you take baking soda, which is this, sodium bicarbonate, with vinegar, and that's also known as acetic acid, and with a chemical change, it makes a totally new substance, which is sodium acetate plus water plus carbon dioxide. Our last change of matter is a nuclear reaction. And we can't perform a nuclear reaction in class because it produces way too much energy. But we're going to talk about it because you still need to know it. So, nuclear energy is stored in the nucleus of an atom, in potential energy. And this energy can be released by joining nuclei together, which is called fusion. And you can remember fusion by thinking of union, joining together. And the other kind of nuclear reaction is fission, which is splitting of a nuclei. And you can think fission is division. So, in nuclear reactions, a small amount of matter produces a large amount of energy. And once again, that's why we cannot do it in class. However, negative effects of this exist, like nuclear waste storage and disposal of that waste. And to just show you the different kinds of nuclear reactions, we have fission, which remember is division. And that is when a neutron hits uranium-235 or another nuclear element, and it splits, and the splitting causes great energy to come out. And then they send off more neutrons that hit other uranium-235 elements, and even more and more and more and more, and it just combusts, and you have a whole lot of energy. And then the opposite is fusion, which is union. And different elements come together, and that causes a whole lot of energy to come out. And that is the conclusion of our changes of matter. Thank you.